Okay, let's do a review of triangles, and let's start with equilateral triangles. So an equilateral triangle would look something close to that. And an equilateral triangle, by definition, has three congruent sides, and it also has three congruent angles. Not only are the angles congruent, we actually know that each angle is 60 degrees. Okay, if this plus this plus this has to equal 180 degrees and they're all equal, then they actually all have to be 60. Okay, so probably the easiest type is an equilateral triangle. And what we just decided right there is an equilateral triangle actually implies an equiangular triangle. And that would be a biconditional statement. If you tell me the triangle is equiangular, meaning all the angles are the same and they happen to be 60, then I know the triangle is equilateral. And if you know it's equilateral, then you know it's equiangular. Again, two words that you need to know. So a triangle can be equilateral if the sides are all congruent, and that's how it's labeled. Okay, let's go to the next version of a triangle. Let's go to an isosceles triangle. And I think that's probably close enough. An isosceles triangle would look something like that. Two sides are the same. And for an isosceles triangle, what we also know is that those base angles are congruent. So we ever talk about the base angles. If we talk about an isosceles triangle, this would be like a leg there, and a leg there, and then kind of the base there. The base angles are congruent because the legs are congruent, and that's the definition of an isosceles triangle. Isosceles. Okay, it's a different type of triangle. Okay, and the main property of an isosceles is that it's given that these two sides are the same, but then the base angle theorem tells us that those base angles are also the same. And that would be the converse of that would be true as well. If you know the base angles are the same, then you know the legs are the same, and you know it's an isosceles as well. Okay, well, we can have all three sides the same. We can have two sides the same, which we would call the leg, or we can have none of the sides the same, and that would be a scalene. And I'll just randomly just try to draw, I don't know, something like that. And let's assume that all of those are different. That may look like maybe that's the biggest, and then that's medium, and that's small. And I'm just labeling them different. It doesn't have to be 1, 2, 3. And that's scalene. And that's me classifying a triangle by its sides. Okay, what if I wanted to classify a triangle by its angles? Well, then we have different words. We can have acute. An acute one is such that all the angles are less than 90 degrees. I don't know if that's equilateral. I don't know if it's isosceles. I don't know if it's scalene. It doesn't matter. What I'm saying is that all of the angles are less than 90. All angles are each individually less than 90 degrees. We can have an obtuse triangle. An obtuse triangle is one that has one angle. Of course, you can only have one angle that's bigger than 90. Okay? One angle greater than 90 degrees. Of course, you can't have two, considering all three add up to 180. That would be that angle in this particular case. And you can have an obtuse isosceles, which with this, if those two legs were the same, and that angle was more than 90, then that would be an obtuse isosceles. You can have an acute isosceles. This looks like an acute isosceles. You can have an obtuse scalene, which is probably what this is. It's an obtuse angle, and all three sides are different. You can have an acute isosceles. Certainly all equilateral triangles are by definition acute. And then you can have a right triangle. That would be a right triangle, meaning a 90-degree angle, and it looks like it's scalene. None of those are the same. Or you could have a right triangle that's also isosceles, meaning you could have a right angle, a little longer, there we go. All right, you could have a right triangle and have those be the same, and then it's a right isosceles. So you can classify triangles by their angles, or you can classify them by their side lengths. And some of them imply the others, meaning if you know it's equilateral, then you know it's acute and things like that. Okay, so those are kind of those main 6 words: acute, obtuse, right, scalene, isosceles, and equilateral, that talk about the angles and the sides. Okay, all right, let's move on and discuss kind of another general property of triangles. Okay, so that was kind of the basics. Now let's get into even some cooler stuff other than just some vocab. Okay, I'm going to draw a triangle, and we're going to look at something. Let's make that side the longest. Then that may be the shortest, and that medium. Okay, so that's the longest side. And we have a medium side. We have a small side. Okay, those are capital letters representing the angles. So angle A, angle B, angle C, vertex A, vertex B, vertex C. So I would say that AB is greater, this side is the greatest, and it's bigger than BC, and BC is greater than AC, meaning I'm ordering the side lengths. And what we learned in class is that the biggest angle, angle C, is across from the biggest side length. So then angle C is the biggest. Then what's next? Well, this is the medium side, so then that's the medium angle. And then the smallest angle is across from the smallest side. Smallest side across from the smallest angle. And visually, that should make sense. This guy is the longest side, and this guy is the biggest angle. Medium side across from the medium angle. If I keep making this side length bigger and bigger, I'm going to keep making this angle bigger. So what we have is we have a relationship that for sure says that the sides are somehow in proportional to the angle. The bigger the side, the bigger the angle is going to be relative to the other side. Again, biggest side across from the biggest angle, smallest across from the other one. Okay, that's kind of cool, right? Okay, let's talk about what it even means to make a triangle. So we can talk about the triangle inequality. And what that means is, okay, I'm going to give you 2 sides. Let's say 6 and 10. And then I have some other side I'm going to call x. And it's like, what can x be so that I make a triangle? Okay, let's say x is smaller than 10. So that means 10 is the biggest side. Okay, I'm going to draw 10 down here. And so I have 6 left and I have x left, and yet I have to make a triangle. Well, to make a triangle, I got to take the 6 and attach it to this end like this. And then I got to attach the x to this side. And you know what? Those things have to meet. So what would x be? Well, what if I bent them down and I barely made them stretch at all? And 6 I almost laid flat there. And then I almost laid this one flat. And they intersected right there. Well, how small could x be? Hopefully maybe it's not obvious at first, but hopefully it is when we talk about it, that x has to be greater than 4. X has to be greater than 4, not equal to 4. Can't be less than 4. What if x was 3? Can you take something that's 10 inches long and then take something that's 6 and take something that's 3 and make a triangle? Of course not. Those two aren't going to meet. These two together have to be bigger than 10. So this has to be bigger than 4. So we know for sure that x has to be greater than 4, not equal to 4. If it was 6 and 4, they would lay completely flat with the 10, and that wouldn't actually form a triangle. That would just be 6 across and 4 across, and there would be no bend to it, meaning no triangle. Okay, so that's the lower bound, but how big could it be? Well, now let's imagine x is the big side. X is the big side. Well, how big can it be? Would you see how if I have 10 here, and I have 6 here, and I lay them almost completely flat, how big can x be? Well, it can't be bigger than 16, and actually can't even be 16. You see how if x was bigger than 16, there's no way 10 and 6 would actually stretch and form some triangle. If it was exactly 16, it would be 10 across and 6, and it would be the same thing. So I have now my triangle inequality. Given two sides, I can pin the third side. It's got to be bigger than 4, but less than 16. Again, strictly bigger than 4 and strictly less than 16. Otherwise, I couldn't form a triangle. There's really only two cases. Either x is the big side. Well, it can't be any bigger than 10 plus 6. Or x is smaller than 10 and 10 is the big side. And it can't be any smaller than 4. Okay? And so what we would say is, if we wanted to write that out in terms of big or small, big, and small, medium, and big sides, the triangle inequality might say something like this. A plus C has to be greater. A plus B has to be greater than C. If A and B are the small legs, those two together have to be bigger than C. Meaning if you lay C flat on the ground, A plus B together have to be bigger than C. Otherwise, how would they ever connect? Okay, so we have the triangle inequality, which is kind of cool of how do you actually make a triangle, or what's possible to make a triangle. Okay, let's go over here and make a little subset. How do you make a right triangle? So we talk about how do you make any triangle. And again, hopefully it makes sense that the closer these numbers are together, the closer and closer it gets to being equilateral, and the more likely it is to be an acute triangle. Just think about this up here. If all three of these are very similar, then the angles are very similar. And if the angles are all very similar, then you're all closer and closer to being 60, 60, and 60. Okay? If you have one massive one, like x is like, let's say this is 14, then this is going to be some big angle. And it's then most likely going to be an obtuse triangle. Okay, so what does it mean to be a right triangle? So a right triangle, again, is 90 degrees. And for us, we prove that in two ways. Way number one is we actually can use the Pythagorean theorem. If you can show me that a squared plus b squared equals c squared, you actually are proving that it is indeed a right triangle. And then the other way we can do it is that you can look at the slope of this guy and the slope of this guy. And what do we have to show? We have to show that the slopes are opposite reciprocals. Again, I know this one is flat, but let's tilt it. If we know that one slope is like 2/3, then the other slope needs to be -3/2. If you knew that this was 2/3 and that was -3/2, then for sure it's 90 degrees. And if this is 90 degrees, then you have a right triangle. So there's the Pythagorean theorem way, and then looking at a coordinate graph and looking at the slopes. Two different ways to show something's a right triangle. Okay, we have what makes a triangle. We have what makes a right triangle. We have the idea of the longest side is across from the biggest angle. And we have all the definitions of what it means to be these particular things: equilateral, isosceles, scalene, acute, obtuse, and right. Hopefully this was a good first start in terms of reviewing kind of the basics of triangles.